Section 8.3 is ultimately another section in solving systems of linear equations. In section 8.1, we learned how to solve systems of linear equations using the substitution and the elimination method. And then in section 8.2, 8.1 was substitution and elimination. 8.2, we learned how to use row reduction and matrices to solve systems of linear equations. In section 8.2, we're going to learn another way to solve systems of equations with something called a determinant. And a determinant is really just a number that's associated with a matrix. And if we create a determinant from a system of equations, we can use the determinants determinant, yeah, that's spelled right. It's just a number, and we can use this number to solve a system of equations. The first few problems give me matrices associated with, gosh darn, a matrix. And these matrices are not representative of a system of equations. We're kind of missing a column for them to be representative of a system of equations. So I'm just going to find the determinant. That's all I'm asked to do. Find the value of the determinant for the following matrices. Two ways to do it. My calculator can do it. I'm going to do it first on my calculator, then show you how to do it by hand. So for number 2, I'm going to find the determinant of this matrix. To do that determinant, I'm going to enter this matrix as matrix A. It's going to be a 2 by 2 matrix. So I'm going to get started on my calculator real quickly here. We know how to enter matrices already, so I'm going to go through that process and enter that matrix. So I'm going to hit the second button, the X inverse key. I'm going to arrow over to edit, and then I might as well enter it in A. There's no reason to put it in another place. So I'm going to hit enter on A, type 2 by 2, and then -2, enter, 4, enter, 3, enter, 1, enter. Have the matrix in, then I do second and quit. That part's not new. The new part is getting the determinant. To get the determinant, I hit the second, again with the X inverse matrix key. Then I'm going to arrow over and get the math highlighted in the middle column. And instead of making my way all the way down to RREF, I'm going to select the DET option and hit enter. I think that's actually going to be the first enter I'm going to have to do. So I'm going to hit second, get to the matrix menu, arrow over to math, and I think my cursor is going to be right on DET, and hit enter. When I do that, just like RREF, when I do that, flashes up on the main screen. My calculator is going to come with that on the main screen. So let me get to there. So second and the X inverse matrix key, arrow over to math, and I'm right on DET with a small d as opposed to a big T, and I hit enter. So that's exactly what I'm going to do. Second, matrix, arrow over to math, hit enter, and now I need to get this to say DETA. And I get it to say DETA just like I got the calculator to do RREFA. So to finish this one up, now I need to go second, X inverse matrix key. It's actually the X inverse key, but matrix written above it is what we're trying to use. And I'm going to leave my calculator under the names and A and hit enter. So again, this is only one enter to get this A written next to the DET. The DET is flashing on my main screen. I need to get the A next to it. That's the process that we already know how to do. We hit second and then matrix. The names and the A is highlighted. I'm going to hit enter, and it's going to get the A next to my DET. If it bugs me, I don't need to close that right parentheses, but I can. I'm going to hit enter one more time, and it's going to give me the number that's associated with this matrix, the determinant of this matrix. And that determinant is -14. The answer to problem 2 is the DET of this matrix is negative 14. In this section, we don't have to do determinants by hand, but I'm going to show you how to do them by hand. So to get this number by hand, it's not particularly hard. So to get negative 14 by hand, I'm going to cross multiply down and go negative 2 times 1, which is negative 2. I'm going to kind of cross multiply up and go 3 times 4, which is 12. And I'm going to subtract these amounts. So the two cross multiplyings you subtract. I'm going to go negative 2 minus 12, and negative 2 minus 12 is going to give me that negative 14. To find the determinants by hand of a 2 by 2 matrix isn't particularly difficult. It turns out that the only matrices that have determinants are called square matrices when the number of rows equals the number of columns. If we had a 2 by 3 matrix up here with 2 rows and 3 columns, you can't find a determinant. Determinants only work for matrices that have the same number of rows as columns. So you should be able to do number 1. Whether you use your calculator or you do it by hand, in this section I don't care. For problem 4, I'm going to do it both ways. First, I'm going to find the determinant by hand. I'm going to cross multiply down and get negative 4 times 0, which is 0. Cross multiply up and do negative 1 times 5, which is negative 5. I'm going to subtract this. I'm going to go negative 4 times 0 minus negative 1 times 5. I produce a double negative here. That's going to be 0 plus 5. The answer to number 4 is just 5. I don't really need to say the determinant of the matrix is 5 because that was a question that was posed. 5 is the answer to number 4. Let me get this now on my calculator. So second matrix, arrow over to edit. In matrix A, I'm entering the 2 by 2 matrix, negative 4, 5, negative 1, and 0. Have the matrix in now. So I'm going to go second and quit. Second matrix, arrow over to math. Hit enter on DET. Get the A to be in the parentheses. So second matrix, hit enter on A, close my parentheses. When I hit enter, it better give me 5, which it does. So you should be able to do number 3. Whether you do it by hand or on your calculator, it's completely up to you. 5 and 6 want me to do determinants of 3 by 3 matrices. These can be done multiple ways, your calculator being one of the multiple ways, and there's kind of 2 ways to do them by hand. A really sophisticated way and a shortcut way. I'll show you the shortcut way, even though maybe the sophisticated way might be nicer to teach. I think the shortcut way is probably better. But I'm going to do problem 6 and find its determinant real quickly by my calculator. This is a 3 by 3 matrix. Has 3 rows and 3 columns. My calculator certainly doesn't care how big the matrix is. As long as it's a square matrix, my calculator can find its determinant. So 1, 0, 1, 7, 2, 4, 2, 3, negative 5. Hit second and quit. If I just hit the second button and enter, it will bring up the last line that I typed. The last line I typed was determinant A. And now it'll find the determinant of this matrix A. So rather than going second matrix, math, hit enter, second matrix, names A, hit enter and close parentheses, and then hit enter to get negative 39. I could have just hit second and enter then enter again, and it'll bring that up for me. So the answer to problem 6, the determinant of that matrix is negative 39, and that has nothing to do with x equal to a number, y equal to a number, z equal to a number. It's just a number that's associated with that matrix. To do this determinant by hand, it's a nuisance. What I'm going to do is take the matrix and write it down. Usually when you're finding a determinant, you kind of put the matrix in absolute value symbols. That's kind of the determinant symbol. And then after those symbols, or after the matrix symbol, I'm going to copy down the first column again and copy down the second column again, but I don't need to copy the third column down. So original matrix, copy the first and the second column, and now I'm going to do 3 sets of multiplying. I'm going to multiply 1 times 2 times negative 5. That's going to give me a negative 10. Then I'm going to multiply 0 times 4 times 2. That's going to give me a 0. Then I'm going to multiply negative 1 times 7 times 3. That's going to give me a negative 21. I want to add these numbers. I'm going to go negative 10 plus 0 plus negative 21. Let me do that real quickly. Negative 10 plus 0 plus negative 21. And I get negative 31 for this computation. The value of the determinant is negative 39. That's not correct yet because I'm not done yet. I have to do the other direction of my cross multiplying. Starting from the bottom left, cross multiply up. First cross multiplying I'm going to do is 2, or up multiplying or cross multiplying is 2 times 2 times negative 1. That's what I have circled there. That multiplies out to be negative 4. Second is going to be 3 times 4 times 1. That comes out to be 12. And then negative 5 times 7 times 0. That comes out to be 0. I want to add these numbers together. Negative 4 plus 12 plus 0. Negative 4 plus 12 plus 0 equals to 8. The determinant, I subtract the down from the up number. So the answer I'm going to get by taking the first number that I computed and minusing the second number I computed. Minus 31 minus 8 is equal to minus 39, which is exactly what the determinant is. One more before we get into solving systems of equations with determinants. So give number 5 a go. I don't care if you do these by hand or use your calculator. I'm going to do problem 8 on my calculator first. So second matrix, edit. It's a 3 by 3 matrix. So 3, 2, 0, 4, negative 1, 3, 1, negative 5, 6. Done with it. Second and quit. Now second matrix math, DET. Second matrix names, A, parentheses closed, enter. The answer to number 8, the determinant of that matrix, equals negative 15. If I want to do this by hand, I have to cake the 2 columns and write them down. The first 2 columns, the first column 3, 4, 1, write it down after the matrix, and 2, negative 1, negative 5, write it down after the matrix. Then I do 3 cross multiplyings down. First cross multiplying down is 3 times negative 1 times 6. That's negative 18. The second is 2 times 3 times 1. That's positive 6. And the last, 0 times 4 times negative 5. Since it has a 0 there, that comes out to be 0. I'm going to add these. Negative 8 plus 6 plus 0 equals to negative 12. Now I'm going to do the other set, starting from the bottom and working my way up. First one is going to be 1 times negative 1 times 3. That's going to be negative 3. And then, oops, I messed up. It should have been 1 times negative 1 times 0. That's why I like to, let me write this down again. I think I was messing up here. So 3, 4, 1, 2, negative 1, negative 5, 0, 3, 6, 3, 4, 1, 2, negative 1, negative 5. I don't think I made a mistake going down, but the first going up should have been negative 1, 1 times negative 1 times 0, and that should have come out to be 0. The second going up is negative 5 times 3 times 3. That's negative 45. And the last is 6 times 4 times 2. That's 48. I need to add these, so I need to go 0 plus negative 45 plus 48. So 0 plus negative 45 plus 48, that's going to equal to 3. To get my answer, I subtract these two numbers. So the determinant by hand is going to be negative 12 minus 3. That's just that minus that. And negative 12 minus 3 is negative 15, which I already knew that was going to be the answer. Okay, done with the first 8 problems. Notice I don't have any answers like x equal to a number, y equal to a number, because these determinants didn't have anything to do with a system of equations. The rest of the problems give me systems of equations that I'm going to solve using something called Cramers Rule. Cramers Rule is a way to use determinants to solve a system of equations. If I wasn't asked to use Cramers Rule and I wanted to solve this system of linear equations, I would do RREFA. And I suggested this. Check your answer by using the RREF feature on your calculator. I'm going to get the answer for problem 10 real quickly by entering a 2 by 3 matrix. And that 2 by 3 matrix has nothing to do with what's new to this section. It's exactly what we did in the last section, 8.2. But if I enter this matrix and do RREFA, I can get my answer. So second matrix, edit, 2, enter, 3, enter, 8, negative 3, negative 2, 2, 1, negative 4. Second quit, second matrix math, RREF, second matrix names, enter. My answer is going to be x equal negative 1, y equal negative 2. That wouldn't get you any points in this section. To solve the system of equations using Cramers Rule, I need to create one more determinant than letters. So I need to create 3 determinants. The first determinant I'm going to call D. The second determinant I'm going to call D sub x. And the third determinant I'm going to call D sub y. D has the coefficients of the x column. The numbers in front of the x's go first. So in the D, the first numbers are the numbers from the x column. And in this particular problem, the numbers from the x column are 8 and 2. Then it has the numbers from the y column. The numbers from the y column are going to be negative 3 and 1. So the first of the 3 determinants I need to compute is D. Let me do it on my calculator because it's safer. So second matrix, edit. D is a 2 by 2 matrix which has 8, negative 3, 2, and 1. Second quit. Second matrix, math, determinant. Second matrix, A, parentheses, enter. The D number is 14. The next matrix determinant I need to compute I call D sub x. And it has the numbers first from the equal column. And the equal column has the numbers negative 2 and negative 4. And then it has the numbers from the y column of this matrix here in the original problem. And those numbers are negative 3 and 1. So the D sub x, I look at this matrix. I take the equal column numbers and write them first. And then the y column numbers and write them second. In the initial D, I took the numbers from the x column, then the numbers from the y column. Let me do this determinant on my calculator again, just because it's so much safer. Second matrix, edit. This is a 2 by 2 matrix. Negative 2, negative 3, 4, and 1. Second quit. I think I could just go second and enter because I just did determinant and hit enter. That makes this number equal to 10. Yeah. I have a sign error or something going on here. Negative 2. Yeah, I think I made a mistake entering A. Let me check A. Second matrix, edit. I did negative 2. Haha. Look, I did -2, fine. -3, fine. I was supposed to do -4. Didn't do -4. Let me change that to -4 and then +1. So I entered a +4 there as opposed to a -4. Had a mistake. I was going to find that mistake in a bit, but let me redo that determinant and get -14. Done with the d sub x number, on to the d sub y. The d sub y has the numbers from the x column first, which are 8 and 2. Then the numbers from the equal column, which are -2 and -4. Let me enter those and find that determinant. So for d sub y, I'm going to enter that matrix as a 2 by 2 matrix. So second matrix, edit, 2 by 2, 8, -2, 2, -4. Looks like I have it in correctly. Second quit, and then just second and enter brings up the last line. Enter again, gives me -28. I've done the 3 determinants. Now I'm going to use the 3 determinants to get the answer, and it's super easy to do. To get the x equal to -1, I divide the d sub x number divided by the d number. X is going to be d sub x over d. You can kind of see the d's cancel and you're left with an x. The d sub x number is -14. The d number is +14. -14 divided by +14 is -1. There's my x equal to -1. Next number I need to get is the y. And y is going to be the d sub y number divided by d. You can kind of see the d's cancel out. The d sub y number is -28. The d number is +14. -28 divided by +14 is -2. So the answer I already knew. The answer was x equal to -1, y equal to -2. The easiest way to do it is just to enter a matrix and do RREFA. But that's not going to be acceptable on the test. On the test, the problem that says use Cramers Rule is going to ask for each one of these things. It's going to be an 8 or 10, actually it's going to be a 10-point problem. You're going to get 2 points for finding out what the value of d, 2 points for the value of d sub x, 2 points for the value of d sub y, and then 2 points for knowing what x is and 2 points for knowing what y is. I'm going to move on to problem 12. I'm going to get the answer on my calculator real quickly by entering a 2 by 3 matrix that's implied by that system of equations. So second matrix, enter a 2 by 3 matrix with 5, 2, 1, 1, -7, 10. Second quit. Second matrix math, go to RREF, and then second matrix names, close my parentheses and enter. Ooh, and then math, enter. If I entered it right, I believe the answer is x equals 27 over 37 and y equals -49 over 37. Let me make sure that I actually enter the matrix 5, 2, 1, 1, -7, 10 by just going second in matrix, hitting enter on A and then enter again. 5, 2, 1, 1, -7, 10. So I entered the right matrix. Now I need to get those answers using determinants. I need to compute 3 determinants, and the matrix that I worked with has an x column, a y column, and an equal column. The D matrix just has to have the numbers from the x column and the y column, which are going to be 5 and 1, which is the x column, the numbers from the y column. You can get the determinant on your calculator, or you can cross multiply and subtract. By hand, I would go 5 times -7, multiplying down, is -35. Multiplying up, 1 times 2 is 2, and I'd subtract. -35 minus 2 is -37. It's so much safer for me to do these on my calculator. Let me do this on my calculator. Second matrix, edit, 2 by 2 matrix. 5, enter, 2, enter. Wow, 1, enter, -7, enter. Second quit. Second matrix, math, enter, second matrix names, close my parentheses, enter, there's my negative 37. The D sub x number has the numbers from the equal column, then the numbers from the y column. The numbers from the equal column in that matrix are 1 and 10. The numbers from the y column are 2 and negative 7. I'm going to do it on my calculator. I don't care to do these by hand. We don't have to on the test. So second matrix, edit, enter this 2 by 2 matrix, 1, 2, 10, negative 7. Second and quit, because the last thing I did was determinant. I could just hit second and enter enter again. This is going to give me negative 27. One more determinant to do. That's the D sub y. And the D sub y first has the numbers from the x column, then it has the numbers from the equal column. The numbers from the x column in that matrix are 5 and 1. The numbers from the equals column is 1 and 10. Let me enter that on my calculator. I think I get 49 for that. So I'm going to go second matrix, edit, 2 by 2 matrix, 5, 1, 1, 10. Second quit, second and then enter again, and I get 49. Certainly could do that by hand. Multiplying down, I'd go 5 times 10, which is 50. Multiplying up, I'd go 1 times 1, which is 1. I subtract 50 minus 1 and get 49. Almost done. Again, on the test, each one of these numbers is going to be worth 2 points. The x answer, which I already know is 27 over 37, I get by taking the d sub x number, which is negative 27, dividing it by the d number, which is negative 37. So x is d sub x over d, negative 27 over negative 37. Those reduce to positive 27 over 37. The y part of my answer, which is negative 49 over 37, I get by taking the d sub y number, dividing by the d number. The d sub y number is 49. The d number is negative 37. My calculator moved the negative up to the numerator, and I'm going to do the same. But you certainly could say the answer to the y is 49 over negative 37. That would be okay. All right, so give 11 a go. These are very repetitive. Once you get it, you get it. At first, it takes a bit to get. So 14, first do it by the old school method. I'm going to create a matrix. The x column is going to have 4 and 3. The y column is going to have 1 and negative 5. The equals column is going to have 11 and 37. I'm going to do RREFA and get the answer so that when I do Cramers Rule, which is solving by determinants, I know that I'm right. So second matrix, edit this as a 2 by 3 matrix, enter the numbers in, make sure I have them right, and then second quit, second matrix RREF, second matrix names, parentheses, enter. The answer is going to be x equal to 4, y equal to negative 5. So I'm not going to really give you points for the answer. When you're asked to solve by Cramers Rule, that implies you need one more determinant than there is letters. The first determinant we're going to call D. D has the numbers from the x column, which are 4 and 3, followed by the numbers from the y column, which are 1 and negative 5. You're allowed to do determinants using your calculator. It's way safer, so I'm going to use my calculator. Second matrix, edit. Enter that as a 2 by 2 matrix. And then second quit. Second matrix, math, determinant. Second matrix, A, enter. So D is negative 23. Now I'm going to find D sub x. D sub x has the numbers from the equal column first, which are 11 and 37. Then the numbers from the y column, which are 1 and negative 5. I'm going to figure out what D sub x is real quickly by entering a 2 by 2 matrix that has 11, then 1, then 37, then negative 5. Second quit, second enter, enter, and get negative 92. Last determinant I need is D sub y. D sub y has the numbers from the x column, which are 4 and 3. Then the numbers from the equal column, which are 11 and 37. I'm going to find out that determinant by doing that on my calculator. So second matrix, edit, and enter 4, 11, 3, 37, second quit, second enter, and that d sub y is 115. Almost done. Now I just need to find out the answers using my strategy of Cramers Rule. X is the d sub x number over the d number. The d sub x number is negative 92. The d number is negative 23. And when you go negative 92 divided by negative 23, you get positive 4, which is exactly what it needed to be. The y number is going to be the d sub y number over the d number. The d sub y number is 115. The d number is negative 23. So on my calculator, I can go 115 divided by negative 23, and I get negative 5, which is exactly perfect. Again, for all of these, I know the answer. So you're not going to get a lot of points for just the answer. Each of the three matrices, the d sub x, and the d sub y, are going to be the bulk of the points when you go to do your work. All right, let's do 15 and 16. Let me just do 15. So on 15, and I won't do 16, pause the video and try to do this and check yourself. I'm going to enter a matrix and get the answer. That matrix doing RREFA is going to give me the answer to problem 15. So let me enter that really quickly. Second matrix, edit, that's a 2 by 3 matrix, 3 enter, 2 enter, 11, 2 enter, negative 1 and 5. Second quit, second matrix, math, RREF, second matrix, enter. Looks like the answer is x equal to 3, y equal to 1. Got to do it by Cramers Rule. Cramers Rule wants 3 determinants. The determinant D has the numbers from the x column first, which are 3 and 2, then the numbers from the y column, which are 2 and negative 1. I can figure out that D by hand by cross-multiplying down. 3 times negative 1 is negative 3, then cross-multiplying up, 2 times 2 is 4, and then subtract those numbers. Negative 3 minus 4 is negative 7. Don't have to do the matrices determinants by hand, but you can. The second determinant is d sub x. First has the numbers from the equals column, which are 11 and 5. Then it has the numbers from the y column, which are 2 and negative 1. I'm going to do that on my calculator. It takes a lot less room, and it's got to be as accurate, probably more accurate. So I'm going to enter a 2 by 2 determinant, 11, 2, 5, and negative 1. Second quit. Second matrix math. Whoops, DET. I just needed to stay there. Second matrix names. Enter. This one comes out to be negative 21. The last determinant I need for problem 15 is d sub y. It has the numbers from the x column first, which are 3 and 2. Then the numbers from the equal column, which is 11 and 5. Do that on my calculator as well. So second matrix edit. That's a 2 by 2 matrix. Then 3, 11, 2, and 5. Second quit. Second enter, and enter. This is negative 7. Have my 3 determinants done. X is going to equal to d sub x over d. D sub x is negative 21. D is negative 27. Those divide to be 3. Y is the d sub y number divided by d. The d sub y number is negative 7. The d number is negative 7. Negative 7 divided by negative 7 is positive 1. So you have to show all of that to get points on the test. An answer, because it's so easy to get, it's not going to get you any points. I overkilled these for problems. I'm going to do 18. If you want to skip 17 and 19 and fast forward to me doing problems 21 and 22, which is going to have x, y's, and z's, feel free to skip 17. Feel free to skip 19. I'm going to skip 20. I'll do 18. So for 18, I'm going to create a matrix that has an x column of 6 and 2, a y column of 2 and negative 7, and an equals column of 26 and 24. I'm going to RREFA this 2 by 3 matrix to get the answer. And again, the only reason I'm teaching you Cramers Rule is because I'm asked to teach it, and in general there's no purpose in doing Cramers Rule so much now. Since our calculators do RREF so quickly, doesn't really save any time. When I learned Cramers Rule back in, maybe 1979, it was cool because matrix manipulation was a nuisance to do, and we didn't have calculators to do it back then. So to get this answer, I need 3 determinants. The first determinant has the numbers from the x column, which are 6 and 2, the numbers from the y column, which are 2 and -7. Let me just find that number. Second matrix, enter a 2 by 2 matrix, 6, 2, 2, -7. Second matrix, math, determinant, second matrix, names, enter. D is -46. On to D sub x. D sub x has the numbers from the equal column first, which are 26 and 24. Then the numbers from the y column, which are 2 and -7. I'm going to enter this and get it done. So second matrix, edit, 26, 2, 24, -7. Second quit. Second enter, enter. Whoa, -230. Surprised me, but I'll live with it for now. Lastly, I need to do the d sub y. The first numbers are from the x column, 6 and 2. Last numbers are from the equal column, 26 and 24. Enter that and get its determinant done. Second matrix, edit, 6, 26, 2, 24. Second quit, second enter, enter, equals 92. Almost done. Next thing I need to do is go x equals d sub x divided by d. D sub x is -230. D is -46. So I'm going to divide those. -230 divided by -46 equals, beautiful that that equals to 5. Y is going to equal d sub y over d. D sub y is 92. D is -46, and then 92 divided by -46 is going to equal to -2, which is perfect. Okay, so I'm going to move all the way on to 27, 28, 29, 30, 25, 26, 27, 28. They're out of order here. How about 21, 22? 23, 24, 25, 26. Maybe I'll skip 27 and 28 because this is going to be silly too. I don't generally ask X, Y, Z problems on the test for Cramers Rule because it's just tedious to do. So initially I'm going to do problem 22 and get my answer. I'm going to have an X column in my matrix of 3, -1, and 1. A Y column of -2, 1, and -1. A Z column of 1, 2, and -4, and an equal column of 15, -10, and 14. I'm going to do RREFA, and I'm going to get an answer that has 3 letters for X, Y, and Z. So second matrix, enter this as a 3 by 4 matrix, then 3, -2, 1, 15, -1, 1, 2, -10, 1, -1, -4, 14. Second quit. Second matrix math, RREF, second matrix names. Enter. My answers are going to be X equal to 5, Y equal to -1, Z equal to -2. So that's the answer to problem 22. And I'm going to get this by creating one more determinants than unknown. So I need 4 determinants. The first determinant I'm going to call D. D is going to have the numbers from the X column, which are 3, -1, and 1. The numbers from the Y column, which are -2, 1, and -1. And the numbers from the Z column, which are 1, 2, and negative 4. I'm going to get that number by entering a 3 by 3 matrix. So second matrix, edit, 3, enter, and just enter this up. 3, negative 2, 1, negative 1, 1, 2, 1, negative 1, negative 4. Have the matrix in, second quit, second matrix math, determinant, second matrix names, enter, D is negative 2. Next matrix I need to do, I'm going to call D sub x. And D sub x, the x column changes to the equal column. So I'm going to have the x, the equal column, the y column, and the z column. The equal column is 15, negative 10, and 14. The y column is negative 2, 1, and negative 1. The z column is 1, 2, and 4. 1, 2, and negative 4. I'm going to enter that and find its determinant. So to do this, second matrix, edit, 15, negative 2, 1, negative 10, 1, 2, 14, negative 1, negative 4. Looks like it's in right. Second quit. Second enter and enter. I get negative 10 for D sub x. Moving down to D sub y. D sub y, the y column changes to the equal column. So I get the x column, the equal column, and the z column. For each of the subscripted letter, that letter's column changes to the equal column and the other columns stay the same. So the x column is going to be 3, negative 1, and 1. The equals column is 15, negative 10, and 14. The z column is 1, 2, and negative 4. Enter this as a 3 by 3 matrix. This is very tedious. 3, 15, 1, negative 1, negative 10, 2, 1, 14, negative 4. Second quit, second enter, enter. I get 2 for D sub y. Last one I need to do is D sub z. D sub z has the numbers from the x column, which are 3, negative 1, and 1. The numbers from the y column, which are negative 2, 1, and negative 1. The numbers from the z column, number from the equal column, which are 15, negative 10, and 14. I'm going to enter that and do a determinant. So second matrix, edit. So tedious. 3, negative 2, 15, negative 1, 1, negative 10, 1, negative 1, 14. Make sure it's in right. Second quit, second enter, and I get 4. Almost done. Now I need to get 3 answers. Same strategy. X is going to be D sub x over D. D sub x is negative 10. D is negative 2. Negative 10 divided by negative 2 is positive 5. There's my x. Y is D sub y divided by D. D sub y is 2. D is negative 2. 2 divided by negative 2 is negative 1. And lastly, z is D sub z over D. D sub z is 4. D is negative 2. 4 divided by negative 2 is negative 2. So I got the answers that I matched up with. Maybe I'll just do one more of these. And you could do problems 21 and 23. I don't ask these on the test, so I think that's a bit overkill. So I'll do 24, you'll do 23, and then we'll just stop there. If you have the urge, do 25. I'm not going to ask a 3-letter Cramers Rule problem on the test. Let me do 24. First, I'm going to enter and get the answer. So I need an x column, a y column, a z column, and an equals column. The x column is 4, 4, 5. The y column is 4, negative 2, 3. The z column is 4, negative 8, 8. The equals column is 12, negative 12, 21. I'm going to RREFA and get my 3 answers. So second matrix, edit this as a 3 by 4 matrix. 4, 4, 4, 12, 4, negative 2, negative 8, negative 12, 5, 3, 8, 21. Second quit, second matrix math, RREF, second matrix names, and I get 1, 0, and 2 in the right-hand column for my answer. By Cramers Rule. First matrix, matrix D, has the X column, the Y column, and the Z column. D sub X has the equals column, the Y column, and the Z column. D sub Y has the X column, the equal column, and the Z column. And D sub Z has the X column, the Y column, and the equals column. For each letter, its column turns to the numbers from the equal column. So the D, I get the X's, 4, 4, 5. The Y's, 4, negative 2, 3. And the Z's, 4, negative 8, 8. Let me get that one done. So second matrix, edit, 3 by 3, 4, 4, 4, 4, negative 2, 8, 5, 3, 8. Second quit, second matrix math, enter, second matrix, enter. This is negative 40. The next matrix has the equal column first, which is 12, negative 12, and 21. Then the Y column of 4, negative 2, and 3. Then the Z column of 4, negative 8, and 8. Let me enter that. Second matrix, oh, I'm so tired of this. 3 by 3 matrix, 12, 4, and 4. Negative 12, negative 2, negative 8, 21, 3, and 8. 12, 4, 4. Looks good. Second quit, second enter, enter. And I messed up somewhere because I get negative 168. That's not good because I'm supposed to divide these two numbers and get 1. That doesn't work. I entered one of them wrong and I'm not sure which. Let me double check this one. Should be second, whoops, matrix, enter. So it should be 12, 4, 4, negative 12, negative 2, 8, 21, 5, 3, and 8. I think that's right. Maybe the first one I messed up on. Let me redo the first one. One number wrong goes doom you. So 4, 4, 4, 4, negative 2, negative 8, 5, 3, 8. Second quit. Second matrix math, determinant. Second matrix names, A. I messed up on that one. That one's negative 168. That makes sense because I'm going to divide these to get the X, and that's going to be 1. I just entered a number wrong. One number wrong makes the whole problem wrong. For the D sub Y, I'm going to have the X column first, which is 4, 4, and 5. Then the equal column, 12, negative 12, and 21. And then the Z column, 4, negative 8, and 8. Let me just enter this and get its determinant. Second matrix edit, 3 by 3, 4, 12, 4, 4, negative 12, negative 8, 5, 21, and 8. Second quit, second enter, enter. I get 0. That's good because 0 divided by negative 168 is going to be 0. Last one, X column first, 4, 4, 5. Y column, 4, negative 2, 3. Z column, 12, negative 12, 21. So tired of this. So 4, 4, 12, 4, negative 2, negative 12, 5, 3, 21. I get negative 336. Done with the grunge work. Now I'm going to get my answers. X equals to D sub X over D. D sub X is negative 168. D is negative 168. Negative 168 divided by negative 168 is 1. Y equals D sub Y over D. D sub Y is 0. D is negative 168. Any fraction with a 0 in the numerator is equal to 0. D sub Z over D equals to Z. D sub Z is negative 336. D is negative 168. Divide those on my calculator. Negative 336 divided by negative 168. And I get 2 for the Z, which is perfect. So my answers match perfectly. So go ahead and give 23 a go. If you don't want to go any further, if you don't want to do problems 25 or 27. That's completely fine. I don't put these on the test, and it's just a bit of overkill here. I think we've done plenty of these to give you a good exposure to Cramers Rule. Like heck.